All right, let's get into it. Today, we are diving headfirst into one of the biggest and, let's be honest, weirdest ideas in all of science, the theory of quantum consciousness. We're going to explore the absolutely wild possibility that the very thing that makes you, you, is actually built from the bizarre, spooky rules of quantum mechanics. So, where do you even start with an idea that big?
Well, it all kicks off with a question that seems almost childishly simple, but it is one of the deepest questions you can ask. Seriously, why does it feel like something to be you? Science is great at explaining how your brain works, which neurons fire, what chemicals are released, but it has no explanation for why you have an inner world, a subjective experience. Why is there a you in there at all?
And this, my friends, is what philosophers and scientists call the hard problem of consciousness. It's the ultimate mystery. How does that 3-pound lump of wetware between your ears generate the experience of seeing the color red, or the taste of chocolate, or just a feeling of being alive? Our classical everyday science just draws a blank.
So, yeah, that's our starting point. A massive, genuine mystery, right at the very center of our existence. But what if the answer isn't in the biology we're familiar with? What if it's hiding in the strange, almost magical world of the very, very small?
This is where the story takes a turn for the truly fascinating. A few very bold thinkers are convinced the clue we're looking for lies in the spooky, counterintuitive world of quantum physics.
Okay, so the thinking goes a little something like this. At the end of the day, everything, including your brain, is made of quantum stuff. We now know for a fact that other biological systems, like plants using photosynthesis, actually use quantum weirdness to be super efficient. So the big question, the million-dollar question is, could our brains be doing the same thing, but to create consciousness itself?
And this isn't just a vague idea. The theory actually zooms in on a tiny, very specific structure inside our brain cells that might just be the stage where this whole quantum show is happening.
So, I want you to meet the microtubules. These are these tiny, hollow tubes of protein, and they're basically the scaffolding and the internal highway system for our cells. They're everywhere, but they are jam-packed into our neurons. And the people behind this theory think they are way, way more than just cellular plumbing.
So why all the fuss about these little tubes? Well, for one, their structure is a repeating, almost crystal-like lattice, which is potentially perfect for hosting quantum effects. And that hollow center? It might act like a little shield, projecting those super delicate quantum states from the noisy, chaotic environment of the cell. But maybe the biggest clue of all, the real smoking gun, is that we know general anesthetics, the very molecules that literally switch our consciousness off, bind directly to these microtubules. That's a pretty huge coincidence, right?
So all of this leads to what's called the ORC-OR theory, which comes from the brilliant minds of physicist Roger Penrose and anesthesiologist Stuart Hameroff. Here's the gist of it in 4 steps. First, proteins inside these microtubules enter a quantum state called superposition, meaning they're in multiple states at the same time. Second, these states get linked up, or entangled, with tons of other proteins, building this massive, coherent quantum state. Third, that state grows until it hits a certain threshold and collapses on its own. And fourth, and this is the absolute game changer, that collapse is a moment of conscious experience. It's one single frame of your reality, happening over and over, something like 40 times every second.
It's an incredible, mind-bending, beautiful idea. But, and you knew there was a but coming, the vast majority of the scientific community is, shall we say, not convinced. So, it's time for a reality check.
And here it is, this single biggest objection you will hear summed up perfectly. Quantum states are unbelievably delicate. We usually only see them in highly controlled labs that are super cold and isolated. The mainstream scientific view is just that the human brain is simply too warm, too wet, and way too noisy for these fragile quantum states to last long enough to do anything meaningful at all.
So you can really see the battle lines drawn here. On one side, you've got this incredible theory that might just solve the biggest mystery there is, why we feel anything. But on the other side, you have this really serious problem called decoherence. That's the technical term for how quantum states just fall apart and become normal, boring old physics almost instantly in a warm place like the brain. Plus, there's no direct experimental proof, at least not yet.
And when we say almost instantly, how fast are we talking? Well, calculations suggest that inside a neuron, a quantum state would basically blink out of existence in less than a picosecond. That's less than a trillionth of a second. It's just nowhere near long enough to be part of the brain processes we know are happening on a millisecond timescale. It's a huge timing problem.
Okay, so we've got a wild, beautiful theory and a very powerful, very serious critique. But why should you care about this debate? Because if this theory, or even something kinda like it, turns out to be true, it changes, well, pretty much everything.
So first up, let's talk about free will. In the normal, classical view of the universe, everything is basically a giant set of dominoes. Your choices aren't really choices. They're just the inevitable outcome of a chain reaction that started with the Big Bang. But quantum mechanics is different. It has genuine, non-negotiable randomness built right into its core. So if our consciousness is tapping into these quantum processes, it cracks open the door for real, honest-to-goodness, non-predetermined choice. It suggests your decisions might not just be a cascade of chemical reactions after all. And then, there's the biggest question of them all. If your consciousness is just the result of your brain's hardware running some software, then when the hardware shuts down, that's it. Game over. You're gone. But one of the most fundamental rules in all of physics is that quantum information can't be destroyed. Now, look, this is not to say you go to heaven or get reincarnated, but it does suggest that the fundamental information that constitutes you might not just be erased. It could, in some way, persist in the very fabric of the universe itself. It's a mind-bending thought. And what about the future? I mean, everyone is wondering if the AIs we're building are ever going to truly wake up and become conscious. Well, if consciousness requires a very specific kind of quantum computation that happens in a unique biological structure like microtubules, then it doesn't matter how powerful a classic silicon-based computer gets. It could never, ever achieve genuine consciousness. It would always just be an incredibly clever simulation, a puppet with no one pulling the strings.
And the ripple effects just keep spreading. This could completely reframe how we approach mental health by actually targeting the physical seat of consciousness. It could offer a scientific framework for those profound mystical experiences of oneness and interconnectedness. Maybe that's just a feeling of quantum entanglement. And it even puts us right back at the center of the universe, raising the bizarre possibility that conscious observers are somehow necessary for reality to even become real in the first place.
Look, the theory of quantum consciousness is absolutely unproven and it is highly controversial. But whether it turns out to be right or wrong, just exploring the idea forces us to question everything we think we know. It challenges us to ask this one final, massive question. Are we simply advanced biological machines? Or are we something more? Are we the universe, experiencing itself?